Recall that an outcome is the result of a single trial of a process of chance called a probability experiment. The set of all possible outcomes in such an experiment is called a sample space. A tree diagram, like the one shown, can be used to systematically list the outcomes in a sample space. So looking to the right, notice that there is a situation where we're trying to figure out how many different specific types of blood types there are. There are 4 blood types. You can have blood type A, B, AB, and O. AB is different than A or B. Each type of blood type has a specific RH factor, whether it's positive or negative. So it's possible that a person of blood type A could have a positive RH factor, and he's referred to as being A positive, or A could have a negative RH factor, and that person is referred to as A negative. And that's true for all 4 types of blood types. They could be either positive or negative. And when you write out specifically what those blood types are, it's called a sample space. The tree diagram is used to organize the sample space. Now, if you are only needed to know the total number of outcomes, you can use the fundamental counting principle instead of trying to create a tree diagram. So the fundamental counting principle states that if you have 2 or more events, if you have an event M can occur in M number of ways and is followed by event N, which can occur in number of ways, then the event M followed by M can occur in M times N ways. In other words, you can multiply the number of ways the first event occurred times the number of ways the second event occurred. In the case of blood types, there are 4 tossable blood types and 2 possible RH factors. Therefore, there are 4 times 2 or 8 possible ways to label blood donations. You can see that in the sample space, there is a total of 8 different specific types of blood. So in example 1, a bicycle manufacturer makes 21 and 24 speed bicycles in 7 different colors and 4 different sizes, frame sizes. How many different bicycles does the manufacturer make? So we've got 2 different numbers of gears that they can have. So the number of gears, there are 2 different combinations or 2 different numbers of gears. You can get either 21 or 24. You would take that times the next category, which is the number of colors. There are 7 different colors. And then you would take that times the frame sizes, and there are 4 different frame sizes. So you would take 2 times 7 times 4, which means this manufacturer makes 56 distinct different types of bicycles. Counting problems can also involve determining the number of different arrangements of objects. An arrangement of a group of distinct objects in a certain order is called a permutation. For example, there are 6 different permutations of the letter A, B, and C, meaning that there are 6 specific orders that you can rearrange the letters A, B, and C. You can arrange them in alphabetical order, obviously, as A, B, C, or you can swap the B and the C, and A, C, B is a different order. So is B, A, C. That's a different order than the previous 2, and there are 6 different specific ways you can order those 3 letters. So instead of writing out the sample space like above, what you can do is apply the fundamental counting principle. So since there are 3 choices for the first letter, once this letter is chosen, there are only 2 choices remaining for the second letter. So you would take the first letter choices, which is 3, take that times the number of remaining choices for the second letter, which is 2, and after that, choosing the first 2 letters, only 1 choice remains. So there's only 1 choice for the third letter. So you would take 3 times 2 times 1, meaning that there are 6 possible permutations of these letters. Another way of writing the product 3 times 2 times 1 is written as 3 with an exclamation point behind it, we read the exclamation point as the word factorial. So 3 factorial means you would take 3 times 2 times 1, and in this particular case, that would equal 6. 0 factorial. It is possible to do 0 factorial, and it is defined as being the number 1. You don't see it very often, but if it does come up, you know that 0 factorial equals 1. Example number 2. There are 8 finalists in a band competition. And how many different ways can the bands be ranked if they cannot receive the same ranking? So in this particular case, we have 8 bands who could all potentially finish in first place. Once the band that finishes in first place has been selected, there are now 7 bands that the judges could select for finishing in second place. Once those 2 bands are chosen, then there are 6 bands remaining to be ranked. Once that band is chosen to be finishing in the third place, then there are 5 bands that could finish fourth place, and so on, all the way down to the final band, the leftover band, that could finish in last place. So it'd be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be a total possibility of 40,320 permutations. Suppose in example 2, though, we wanted to know how many different ways that only the first, second, and third place rankings in the competition could be awarded. This also involves permutations, but since you're only ranking the first 3, we're only trying to figure out which 3 bands the order could get a gold, a silver, and a bronze, is we would again take the number of bands that can be chosen to be selected in first place times the number of bands that could be second place times the number of bands that could be third place. But the other remaining bands, their order does not matter. So in this particular case, if we just wanted to rank the first 3 bands, the number of permutations is 8 times 7 times 6, which would be 336. The notation for this situation is NPR, N meaning the number of distinct objects that we have to choose from, and the R means the number of objects we're actually selecting. So in this particular case of 8 times 7 times 6, that permutation could be written as the notation little 8, because we're choosing from 8 bands, permutation, so a capital P, little 3, which means that we're going to be starting with the number 8 and then multiplying that times the first 3 numbers, counting down, starting with the number 8. So 8 times 7 times 6, which we already know is 336. A common mistake, you don't want to do this, but I'll point it out as it is a common mistake, is to try to count down all the way to the 3. That is not what that means. It means start at the 8 and count down the first 3 numbers starting with the 8. So that would be 8 for the first number, 7 for the second number, and 6 is the third number. So how many different ways can 2 students be assigned to 5 tutors if only 1 student is assigned to each tutor? So we have 5 tutors, and only 2 students are going to be assigned to these 5 tutors, and one tutor is not going to get both students. So this situation, since would be 5P2, that means 5 possible groups to choose from, 5 tutors to choose from, but we're only choosing 2 of them to assign these 2 students. So that would be 5 times 4. So starting with the 5, counting down the first 2 numbers, so 5 times 4, and that equals 20.